Hey, mathletes, here we are looking at inequalities in triangles. It's going to be a section 6.566 in our notebook. We're going to be able to order sides and angles of triangles using properties and theorems about triangle inequalities. So yesterday I had to do a investigation on looking at measures of sides of triangles and their angles. So, and fill out that Google form. So what I wanted you to be able to see on this is that as you look at, let's say, your smallest angle. So for this triangle I have right now, 31.4 is my smallest angle. So if I go ahead and look at that angle, okay, and the side that is opposite of that angle, I look at, and that is also going to be our smallest side. BC is the smallest side, and it's opposite of our smallest angle. Our largest angle was 90 degrees here. What's opposite of 90 degrees, the side length here, 13.9, is the largest side of the triangle. So no matter how we move our triangle around, so let's just get another iteration of a triangle here. Okay, and I look at here, so again I see, well, my smallest angle here is 32.5, so opposite of that is 6.5, and that is my smallest side of my triangle. So the relationship of the order of our sides are directly in relationship to this angles opposite those sides. Okay, so let's look at how we can define those theorems. Okay, so the triangle longer side theorem says if one side of the triangle is longer than the other side, then the angle opposite of that is larger than the angle opposite the shorter side. So here we see 8 is larger than 5, so the sides AB is greater than BC. So then we can also say this angles that are opposite of them. So this angle C is opposite of 8, so that is going to be larger, greater than um, our angle A, which is opposite of A. Okay, triangle larger angle theorem is analogous to this, just going the other direction. If one angle of a triangle is larger than another angle, so it's more the converse of it. So if this angle is larger here, then we know the opposite side is larger as well. Okay, so C is smaller, so BA is going to be smaller than BC. Okay, so how can we apply this? So looking here, we're constructing a stage prop that shows a large triangle mountain. Okay, the bottom edge of this mountain is 32 feet. So this is 32 feet. Okay, the left slope is 24 feet, and the right slope is 26 feet. Okay, list the angles of our triangle in order from smallest to largest. So in order to do so, I'm just going to look for my smallest side. So my smallest side is 24. So the angle that is opposite that is angle L. So angle L is our smallest angle. The next largest side is this side of 26. Okay. The angle opposite that is angle J. So angle J is larger than L, but not as large as the angle that's opposite of 32. 32 is our largest side, so that this side over here, this angle, is going to be our largest angle because it's opposite our largest side. Okay. Next example here, similar, ordering our sides from smallest to largest. So again, I'm looking, if I'm going from smallest to largest, I'm again going to identify the side that's smallest, 5.9. What's opposite that is angle Q. My next largest side is 6.2. What's opposite of 6.2 is angle P. And what's opposite of 6.8 is angle R. Okay. On the other one, we're going to use the idea of the angles. So again, we're going from smallest or shortest to longest. So looking for the shortest side, it's going to be opposite our shortest, smallest angle. So our smallest angle is 29 degrees. So the side that's opposite that is ST. Okay, the next largest angle is 30 degrees. So what's opposite of that is RS. And the largest side, therefore, by default, has to be our RP. Okay. So as another inequality we want to think about is comparing our side lengths of triangles and possible side lengths. Okay, so we think of a triangle and it has a side length of 14 centimeters. Okay, and we also have a side length of, let's say, 9 centimeters. Describe the possible lengths of the third side of our triangle. So as I kind of think of these, I think about my extreme conditions. So my extreme conditions is kind of where these two triangles are, where these two lines meet. So if they meet here, and this angle is extremely obtuse, okay, something like this, maybe even, I can't get it to quite rotate exactly how I want it to, but just nearly flat, okay, at this third side of the triangle here, bear with me here. Let's see if I can get the line tool here to work. So let's use a different color. So this side here is almost going to be flat, where we can have a triangle at this extreme case here, but this green line can never be longer than these two sides combined. Even if for some reason we kind of look at this and say this obtuse angle is like the angle here between the green or the blue and the red line is 179 degrees. This line segment at most is going to be able to be that green. So we'll call green's length X. The X has to be less than 9 plus 14. There's no way that this side length could be any longer. Otherwise, those two sides just aren't going to meet. So at most, it's going to be close to it, but it can't be equal to it. So that this side length has to be less than these two angles added up. So it has to be less than 23 centimeters. Okay. Well, if we think about it the other way, and let's the other extreme scenario, okay, it is not that we have a huge obtuse angle where these two lines meet, but maybe we have a really small acute angle. So if we have these triangles meet, and this angle where they meet is super small, okay, we still have to make up this difference, okay? So this length here, X, the smallest side has to be able to add so that they connect the two different vertices of these triangles. Okay, so we got to make sure that when we look at our value here, that X plus our blue length of 9, okay, they have to be less than our red length is 14. So if we subtract 9 from both sides, we're going to see that X, okay, I'm sorry, it can't be greater than, it's got to be greater than, okay, because as we move this line segment and we rotate it further up, okay, we're going to see that this line's going to grow. So we actually get, sorry, let me rewrite that inequality, that we get X plus 9 has to be greater than that 14. Okay, so as we look at that, that means that X, subtract 9 from both sides, we're going to have X is greater than 5. Okay, so combining this idea with our previous idea, describe the possible lengths of the third side, Well, our third side being x, it's going to have to be greater than 5, okay? But it can't be more than 23. So it's fitting in this number line of possible solutions from 5 to 23 such that it can be values close to 5, not including 5, and anywhere in between up until 23. It can't be equal to 23, so it's not inclusive, but it's going to be able to be very close to 23. Okay, so as we look at this theorem, this is how it's laid out. That the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so to be a possible triangle, we have to make sure that all three of these are true. So these must be true to be a triangle. Okay, so how are we going to utilize that? So here in this question, it says a triangle has one side length 12 and another side length of 12. Describe the possible lengths of the third side. So if we let, again, that third side, I think one of the easier ways to think about this is describe the possible lengths of the third side. Let's call this third side x. Okay, so we know that x plus our other length 12 has to be greater than 20. Okay. We also have to show that x plus 20 has to be greater than 12. Okay. And then we also have to show that 12 plus 20 is greater than x. So we got to make sure all these are true. So what are the possible values that are going to make sure that all of these are true? Okay. So as we look at this first one, if we simplify this, so if we simplify this one and we subtract 12 from both sides, we're going to get x has to be greater than 8. Okay. Here, if we subtract 20 from both sides, we get x has to be greater than negative 8. Okay. And here, we see that x, we add these together, they're 32. So x, if we switch around this inequality, so this is pointing to my x, so pointing to my x, and it's opening up to 30, being larger. So I can say that x is less than 30 degrees. It's the same thing as saying that 30 degrees is greater than x. Okay, so looking at these, the ones that make the most sense is that I have to have x's that satisfy all these conditions. Okay, or these restraining conditions. So this being negative here, we're not really concerned with that. What we want to look at is these two values. So we see that our x value, okay, has to be greater than 8, but it has to be less than 30. And so those are our possible side lengths for triangles with a side length of 12 and 20. Okay, so the best thing to do is think about subtracting your largest side given from your smallest side given, and that meets that condition. Okay, and then if you, oh, somehow I got my numbers mixed up, not 30, but 32, so this should have been 32, and so this one ends up being 32. And then this number ends up being the sum of these two numbers. Okay. So on number 4, looking at it, it's giving us 3 possible lengths and then pretty much asking, can we construct a triangle given these lengths? Okay, so if I look at these lengths, I have to make sure all those inequalities are true, that if I take any two, that they're larger than the other one left. So if I do 4 plus 9, is that greater than 10? 13 greater than 10? Check. If I do 4 plus 10, is that greater than 9? So 4 plus 10, 14 greater than 9, check. Okay, if I do 9 plus 10, is that greater than 4? Check. So yes, this can construct a triangle with those 3 lengths. Okay, for the next one, okay, if I look at them, okay, and I do 8 plus 9, okay, is that greater than 18? Well, 8 plus 9 is 17. That is not greater than 18. So no, we cannot construct that triangle. Okay. Another one here, notice that if we do 5 plus 7, okay, is that greater than 12? Well, it's equal to 12. It's not greater than. We don't allow inclusion there. So since it's not, so that's not true. No, this cannot be lengths of a triangle as well. Okay, it's our last examples here. On 5, if PR is congruent to PS, so we have the markers there, okay, and the angle, so angle Q, so let's look at this, maybe help with some colors. So QPR, so this angle is larger than this angle, QPS, it's larger than that one, okay, which is longer, SQ or RQ. Okay? So if I'm looking at this, I know that opposite sides of opposite larger angles are going to be larger. So this angle right here, QPR, is larger, so SQ is going to be larger than, so SQ is going to be larger than RQ. Okay, our last example here, if PR and PS are again congruent and RQ, so the segment RQ is smaller than SQ, so this length is smaller than this length, okay, which is larger, okay, angle RPQ or SPQ, which are opposite of the sides given. So I look for the larger side length was SQ, so the larger angle is going to appear opposite of that side. So that angle is SPQ is larger than angle RPQ. That concludes the notes today on inequalities and triangle. Please bring any questions you might have to our office hours.